So in this video, I'm going to be going over the practice test for the Chapter 9 test. The first question wants me to find the six trig functions for theta. It wants me to write my fractions in simplest form. Tells me quite a few times. So my theta is right here, and then I have 9, 15, and 12. Remember, I should start off by labeling my sides as opposite, adjacent, and hypotenuse. Hypotenuse is always across from the right angle. Adjacent is the side that touches the angle that isn't the hypotenuse. And opposite is the one across from the angle. So now that I have these labeled, I want to use my trig functions. I can use the ones from my 9.1 notes. I have sine, cosine, tangent, cosecant, secant, cotangent. And I have their ratios, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. So, this one wants me to write them out. I have sine. I'm going to write them off to the side up here, and then if I need to simplify, I'll write them down there. So I have sine is opposite over adjacent. Opposite over hypotenuse, so I have 12 over 15. What I can do is I can go to Desmos. I'm going to use the scientific calculator because I know I'll need it later. But I type this in, and then there's this square over square button. If I click it, it turns it back into a fraction. So 4/5 is my simplified sine. Then I can do the same thing for cosine. This is adjacent over hypotenuse, so 9 over 12. Again, I can go to Desmos and type this in. Did I say 9 over 12? It should be 9 over 15. 15 is my hypotenuse. And then again, I fraction it to turn it back into a fraction, which gives me 3/5. I want to do the same thing for tangent. This one is opposite over adjacent, so 12 over 9. Again, I can go to Desmos and simplify this. Which gives me 4/3. Cosecant is the reciprocal of sine, so I flip sine, so it's hypotenuse over adjacent. Hypotenuse over opposite, which gives me 15 over 12. Or I can just flip my sine, which was 5/4. If I type this into Desmos and simplify it, it'll give me the same answer. Secant flips cosine, so now I have hypotenuse over adjacent, so 15 over 9. This will simplify, so 5/3. Cotangent is the reciprocal of tangent. This flips it, so I'm going to have adjacent over opposite, so 9 over 12, which simplifies to 3/4. Number 2 tells me sine of theta is 5 over 13, and I want to find the rest of them. So I'm going to start off by drawing a triangle. I know sine is opposite over hypotenuse, so I label this. My hypotenuse is here, opposite, adjacent. I can go ahead and fill in my pieces that I do know. So I know my 5, and I know my 13. I need to go ahead and find my adjacent value. So I can use the Pythagorean theorem. Remember, that is a squared plus b squared equals c squared, and c squared always has to be my hypotenuse. So I'm going to label my triangle again. This is C. I'm going to make this one A to keep it consistent, and then B. So I have 13 squared. Nope, not 13. I wanted A squared first. A squared plus 5 squared equals 13 squared. 5 squared is 25. 13 squared is 169. I want to go ahead and subtract 25 on both sides. This gets me a squared equals 144. I can take the square root of both sides. I want to go to Desmos to see if this works out nicely. I can type the letters SQRT, or I could click the square root button that's right down here. 144 gives me 12. So I'm going to fill in my missing side length. Now that I know it, I can fill in my ratios. I have cosine should be adjacent over hypotenuse, which is going to be 12 over 13. Tangent is opposite over adjacent, so 5 over 12. If I tried simplifying these ones on Desmos, they will give me back the same fraction. Then I have my reciprocal functions, so I want to go ahead and flip them. Cosecant flips sine, so I'm going to have 13 over 5. Secant flips cosine, so that's going to give me 13 over 12. And cotangent flips tangent, so I have 12 over 5. Number 3 gives me this triangle, and it wants me to find the value of x. So what I can do is I can label my adjacent, hypotenuse, and opposite. This is my hypotenuse, it's my longest side. The angle I care about is the 53, so this side below it is the adjacent. The one not touching that gray shaded part is my opposite. Then I'm going to write out my abbreviation, SOHCAHTOA. And I want to cross out anything that's not being used by the letter that doesn't have something printed next to it. So O has an X, H has a 15, A doesn't have any side lengths. So I don't want to use anything that has an A. So I cross out the two functions that have an A. I'm going to write this out as sine. Because I know that my angle is 53 degrees, I'm going to have sine 53 equals opposite over hypotenuse. So x over 15. Then I want to treat this just like a normal equation. So if I was trying to get x all alone, the way I would do that is I would multiply both sides by 15 because it's currently being divided by 15. So when I do this, it cancels out on my right side. I'm going to rewrite my left side just so I know what I'm typing into Desmos. And this is the part where I want to make sure I am on Desmos Scientific because Desmos Graphing will do it in radians. So again, I'm going to write down that website for you. This is where I'm going to go to type in that equation in blue. So I have 15 sine 53, which gives me 11.9, and then I'm going to round because the number after the 7 is a 9, so that's going to round up to 8. 11.98. Remember when it says nearest hundred, this is 2 decimal places. This one tells me in a right triangle, x is an acute angle, and tangent is 1 over the square root of 3. So this is kind of like number 2, except I only have to find one angle. Remember, tangent is opposite over adjacent. So if I sketch this out, I have my hypotenuse, my opposite, and my adjacent. It told me opposite was 1, adjacent was the square root of 3. I want to find the value of cosine, so I need to know my hypotenuse. I'm going to label these again for A, B, and C. C is always the hypotenuse. I usually keep A the same, so it's less to remember. And then B is the last remaining side. So I'm going to plug in. I have the square root of 3 squared plus 1 squared equals C squared. When I square root a radical, it cancels out, so I'm just left with 3. If I'm ever unsure, I can go back to Desmos and check. So I could do, square root of 3 squared gives me back 3. 1 squared is 1, c squared is c squared, 3 plus 1 is 4. Then I take the square root of both sides. The square root of 4 is 2. So now that I have my information, I can find cosine. Remember, cosine is opposite over adjacent. So my or not opposite, adjacent over hypotenuse. I was thinking tangent. My adjacent was the square root of 3. My hypotenuse is 2. So my answer here is square root of 3 over 2. Number 5 wants me to convert to degrees. Remember, when I'm converting to degrees, I multiply by 180 over pi. So I have 5 pi 6, and I'm multiplying by 180 over pi. My pi's, since I have a pi on the top and bottom, will cancel out. This will give me 5 6 times 180, and I can go ahead and type that into decimals. Which gives me 150. Then I need to decide which quadrant this is in. So remember, if I'm looking at a coordinate plane, it goes 0, 90, 180, 270 for positive degrees. I have 150, that's between 90 and 180, so my angle is right there. Also remember, quadrants are labeled counterclockwise, so it goes 1, 2, 3, and 4. So this would be quadrant 2. The number 6 wants me to convert to radians. So to do this, I'm going to take my 108 and multiply by pi over 180. When I'm converting to radians, I always leave the pi. So I'm just going to rewrite this as 108 divided by 180, and the pi off to the side. So I'm going to take just the fraction part and go to Desmos and type that in. And simplify the fraction, which is 3/5. So my final answer is 3 pi fifths. Then it wants to know what quadrant. So I have 0, 90, 180, 270. 108 is again between 90 and 180. So this is again quadrant 2. Number 7 tells me a motorcycle wheel has a diameter of 20 inches. When rotated by an angle pi force radian, what length of the arc is created by the angle in inches? Reduce the fraction if necessary, and to use the word pi in my answer. So this one is arc length. And I want to use S equals R theta, where theta is in radians. R, remember, stands for my radius. So on a circle, if I have a diameter, that's the whole way across. The radius is just half. Oops. Just half. So I need to take this and divide by 2 to turn it into a radius. So my radius is 10. And then my angle is pi force. So my formula has me multiplying my radius, which was 10, by pi force. I can rewrite this as 10 over 4, and then the pi off to the side. So I simplify my fraction, which gives me 5 halves. When I type this into Canvas, I want to be careful, and I want to make sure that my pi is on the top of the fraction. So I'm going to type 5 pi, and then my fraction 2. Otherwise, it might mark you wrong. So. Okay. Number 8 kind of gets cut off. It wants me to use the values shown in the first quadrant to find the sine and cosine of 120. So 120 is right here. This one is not a very nice unit circle. So what I recommend is taking out your 9.3 notes that I gave you, which has this, the full circle written out. What angles did we want? We wanted 120. So 120 is right here. That is negative 1/2 square root of 3 over 2. Remember, from 9.3, our sine is y, our cosine is x. So on this one, sine is square root of 3 over 2, and cosine is negative 1/2. And I just took those by taking my x and y values. So this one would be my second choice. Number 9 tells me 4, negative 3 is a point on the terminal side of angle theta in standard position. It wants me to find the error below. So I am going to plot this. 4, negative 3 is right here. I'm going to label my hypotenuse, opposite, and adjacent. So hypotenuse is always the radius. Opposite is the one not touching the angle, and adjacent is right here. Tangent, remember, is opposite over adjacent. So on this one, they confused the opposite and adjacent sides. The correct answer is negative 3 over 4. I forgot the word is. Okay. Number 10 tells me the angle of elevation from a point A on the ground to the top of a flagpole is 48 degrees. So angle of elevation is at the bottom. And then it tells me the distance between the point A and the base of the flagpole. So let me draw a flag. Ooh, not a good flag. Is 55 feet. What is the height of the flagpole? So I am searching for this. I'm going to label hypotenuse, opposite, and adjacent. So I want to write out SOHCAHTOA so I know which trig function I want to use. The letter that doesn't have a piece of triangle information is H. So I don't want anything with H. That leaves me with tangent. So I have tangent of 48, the angle, equals opposite over adjacent, x over 55. Again, I want to get this fraction alone. So I'm going to multiply both sides by 55, which will cancel out my right side. And then on the left side, I just want to go ahead and type that into decimals. Left side. Which gets me, this one wants my answer to the nearest whole number, so 61.